Okay, recording. Good. So, where was I? Right. So, the moral of this story is use the answer from the previous part to help you to find your second derivative evaluated at x equal to 0. You do not want to try to make d2y by dx squared the subject in terms of the algebra first and then substitute x equals 0. That's very slow. That's very slow. You just sub in x equals 0 straight away into equation 2, which is what we did over here. And then you realize, oh, actually, I already know what's dy dx. I already know what's y. I can replace them with the corresponding values when they were equal to 0. Oh, and you do the same with the d3y. Or I should have written down. Right? You're substituting into the equation 3. Okay? You know? Yeah, then you just use the formula. Just a recap again, the formula goes a0 plus a1x1 plus a2x2 plus a3x3, where in general an equals to, what is it? The nth derivative. When you sub in x equal to 0, you divide by n factorial. Can? Okay, good. All right, then that is this part B. How about part C? Using the standard series expansion, show that e power sine inverse x is approximately e power 2x plus kx cubed, where k is a constant to be determined. Right. Okay, so there's a plus x going on. There's a plus x going on. So let me just copy the equation first. Never mind, I'll just write it there. E power sine inverse x plus x. So please look carefully. The plus x is on the power of e. So it is want to show. Oops, where is my undo button? It disappeared. Oh, it's there. Oh, yeah. Okay. This is approximately e power 2x plus kx cubed. Okay, so now how do you show that? WTS want to show. What you need to see is e power sine inverse x plus x. It's actually it's actually just e power sine inverse x. Then you multiply by e power x. Agree so far?
Okay.
Right. Then if you want to show it's approximately e power 2x plus kx cubed, that just means that you need to show left-hand side is the same as right-hand side. So let's focus on the left-hand side first. On the left-hand side, we got this guy. E sine inverse x, we already found the answer. It's this guy, right? So I'm just going to recycle the answer we got from part 2. It's 1 plus x plus half x squared plus 3 factorial is 6. 2 over 6 is 1/3. Or another way to evaluate the 2 over 3 factorial here is 2 over 3 times 2 times 1. The 2 cancel away, left with a 1 on top. So 1 over 3 times 1 times 1 is 3. 1/3. X power 3. That's a e sine inverse. I'll just put an approximation symbol here because I'm not expanding more. And e power x, you have to use the MF26. So in the MF26, you see e power x is actually equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial over here. Right? Then I'll just copy. I'll simplify as well. 2 factorial is 2, 3 factorial is 6. I don't need the rest. I just need up to x cubed. Because on the right-hand side, you see, it's only until x cubed. So you just need to figure out what is the constant, the coefficient in front of the x cubed. So here, how about Okay, what should we do? I guess we can expand this whole thing. I think it's, should I expand? I'm not sure if I should expand this or not. Would it be a waste of time? Would it be a waste of time? Because you have to multiply, you have to, how many terms are there? 1, 2, 3, 4. 1, 2, 3, 4. 4 times 4, 16 terms. Let's just not expand it first and deal with the right-hand side. We'll come back to it if we need to expand. See if we can take any shortcuts. So let's just go to the right-hand side first. E power 2x plus kx cubed. And e power 2x. Okay, this time we are just going to use the formula again, but replacing x with 2x. This one don't need bracket because you're not going to square anything. And 2x. This one you need bracket. Power 3 over 3 factorial. Just up to power 3 will be fine. Then 1 plus 2x plus, what's this again? 4 over 2 is 2. 2 cube 8, 8 over 6, 4 over 3. Did I calculate correctly? 8 over 6, 4 over 3. Yeah. Okay. Then x power 3. Okay, approximately. Then how? This is e power 2x plus kx cubed. I forgot a kx cubed. Yeah. Plus kx cubed plus kx cubed. Okay, then that means that these two can combine together. This will become 4 third plus k bracket bracket x cubed. Right? I'll just copy everything else. Maybe at this point I can put those in then. It's equal to the line above. Okay, so what this means is that we should be clever about this. The left-hand side and right-hand side are equal, correct? Approximately. So that means that all the terms are equal. So we can do what's called comparing coefficients. Should we compare the constants? How to get constant? 1 times 1. You get a 1. Is that relevant to helping you solve for k? No. So we stop. Then what do we do next? We compare coefficients for x terms. How do we get x terms? 1 multiplied by x multiplied by 1. That will give you x plus x, which is 2x. Then we get a 2x over here. Okay, that's correct. But is it relevant to helping us get the k? No, not relevant. So we ignore it. How about x squared? Of course not. The only term that's relevant should be which one? Related to k must be the coefficient of sorry?
The last
one. The x cubed term. Right, this is the right hand side, x cubed. So now we focus on the left hand side. Now it was a correct call to not expand out all 16 terms. Because all that I need to solve for k is to focus on the x cubed terms. So how do you get x cubed terms? So let's see. 1 times what gives you x cubed? This guy? X times what gives you x cubed?
x squared.
X squared. So we go here. X squared times what gives you x cubed?
X to the power of 1.
X power 1. X cubed times what gives you x cubed? Constant. So you only need to expand out 4 of the 16 terms. Still quite painful, but a bit more efficient. You see that? You get to go 4 times faster. Okay, anyways, so from here you can expand out the x cubed term. Put a colon like this, and I'll just okay, you know what? I don't even want the x cubed term. I just want the coefficient of the x cubed term. So the first pair, 1 times x cubed over 6, that gives me 1 times 1 over 6 plus, and I'll just put a tick for the ones I completed already. Maybe I'll use green color. Tick. Okay, next one, x. This one, next one. Okay, highlight first. X times x squared over 2. That gives me half x cubed. Or more importantly, is the coefficient 1x times half x squared. So it's just 1 times half. Plus the next one is half x squared times 1x, half times 1. And finally, the last one is 1/3 x cubed times 1. 1/3 x cubed times 1, I end up with 1/3 times 1. Okay, then you just type in the calculator. So let me just quickly do that. Where did my calculator go? You cannot see. Yeah, I need to change screen. Move to the left, then multiply 1 times 1/6 plus 1 times 1/2 plus half times 1 plus 1/3 times 1. Okay, don't need times 1. So you get 3/2. Right? 3/2. Good. Can now? Okay. Coefficient of x cubed got already. So we have it over here and over there. Yeah. Okay, I'm sorry, I didn't take it out. Did you catch what I'm doing over here? How to expand all these terms? I didn't take it as I went through. Can follow? Yes, no? I cannot hear you.
Yeah.
Can follow? Okay, very good. So now that you have the coefficients of x cubed on the left and on the right, you just need to equate them. So 4/3 plus k equals to 3/2. Equate coefficient COEFF of x cubed. So that means you get this, then solve. Okay, 3/2 minus 4/3. Is it clear? Can?
Mm-hmm.
Okay, move on. Next. Where are we? Okay, solve okay already. Okay, next one. Go. Go faster. Go faster. Haven't covered integration techniques. Okay, so question 6, let's see. dy dx equals to 2 times root 1 plus y squared. So part A, you want to show that d2y dx squared equals to 6y squared. So let's take a look. dy by dx equals to this guy. So we can just differentiate both sides with respect to x. D by dx. Then the left-hand side becomes d2y by dx squared. The right-hand side here, the 2 can factor out. Then you differentiate this guy. Please be careful here because it's y. So that means we have to use implicit differentiation. So square root is really just power half. So you bring down the old power, keep the base, minus 1 to get the new base. Half minus 1 is negative half. Times the derivative of the 1 plus y squared. You get 2y. Times, what else?
D
dy by dx, the tail. Okay, then simplify. 2 half cancel away. 2y in front. Multiply by this is power negative half, you can bring down. So you end up with 1/1 plus y squared power positive half. Positive half power, I'm going to skip a step and rewrite as a square root. And I'm going to remove the brackets to make it look neater. And then times 2y, I can bring it up to the numerator. Is that okay?
Mm-hmm.
And I erase and write down, I hope you're not confused. Then you times dy dx. All right, good. So how? d2y dx squared equals to 6 times of y squared. How? Doesn't look anything like 6y squared. Why is this equal to 6y squared? What's the irritating guy that's not supposed to be here? I see y's, that's good. I see square root, that's no good. I see dy dx, that's also no good. You can't really
differentiate both sides.
Differentiate both sides are no, because here the left-hand side is d2y dx squared. The goal is to show d2y dx squared equals something. You differentiate, you're gonna go to d3y dx cube, even worse. Oh. Here, the trick is a clever substitution. Maybe because I wrote down in red color d by dx, then you didn't see this. Let me rewrite it, the original equation again. So it's always good to copy down the original equation first before you write down the derivative one. Yes, very good. You can substitute in. Very good. And cancel away. dy dx is really just 2 times of this square root, whatever. Then the square roots cancel away because they're the same. Left with 2 times 2y, which is 4y. Did I do something wrongly? That's not right. Oh. Wait, let me double check. 1/2 minus 1. Chain rule 2y dy dx. 2 cancels 2y on top. Square root below dy dx. dy dx is 2 times of this one. Ah, was it a typo? I think I meant for this to be a y. Hold on. Yes, it was a typo. I am so sorry. The question was wrong. This was meant to be a y, not dy dx. I'm so sorry. Ayo. Can we redo this question?
Mm.
Yeah. So, anyways, this should have been a y. So we end up with dy dx only. Okay. So that means that we don't have this dy dx tail yet. Okay, good. Then dy dx looks like this guy, 2y over square root 1 plus y squared. Then here, what can we do? We can differentiate again using quotient rule, but I think it would be smarter if we do the following. First multiply by the root 1 plus y squared. Dy dx equals to 2y. Then you differentiate both sides. Okay, then we have to use product rule. So just keep the left guy, differentiate the right guy, plus keep the right guy, differentiate the left guy. So differentiate square root 1 plus y squared. You realize that it's actually almost exactly the same as this guy. It's just no factor of 2, right? So it's really just half of it. So it's just y over square root 1 plus y squared. Do you see how I did that? So if I differentiate on the left, I end up with derivative of this 2 times square root 1 plus y squared. And then I factor out the 2, right? So it's 2 times of d by dx of square root 1 plus y squared. Then I already got the answer. It was a 2 times y over square root whatever. So that means that if I only want this piece without the times 2, I just get rid of the 2. So then you can save some time. You see that? You see a trick? Cancel off the 2 on both sides. Can? Yes, no? Yes, huh? Okay, good. So that's the left-hand side. Then right-hand side, differentiate 2y, you get 2 times the dy dx tail. Okay, very good. So now you have to manipulate it so that you can show the d2y dx squared equal to 6y squared. How? Let's see. I think we can just substitute the dy dx. Oh, substitute in the dy dx first. Plus dy by dx, which is how much? 2y divided by square root 1 plus y squared. Multiplied by y over square root 1 plus y squared. Equals to 2 times 2y over square root 1 plus y squared. Like this, right? Can? Then you realize that square root and square root, they cancel away, becomes 1 plus y squared. Then this is 2y squared. Equals to 2 times 2 is 4y over square root 1 plus y squared. Oh, this is looking a bit too complicated. That means plus sign. Doesn't seem right. But okay, let's just continue. So what we want to show d2y dx squared is that expression 6y squared. So we can just make d2y dx squared a subject. So let's do that first. Bring everything else to the right hand side first. This 2y squared over 1 plus y squared will be overcome minus. Then you can multiply top and bottom here by root 1 plus y squared. And this becomes what? This becomes just 1 plus y squared. Then 4y times root 1 plus y squared. Oh, something is wrong. Minus 2y squared over 1 plus y squared. Then I can combine into a single 1 plus y squared. 4y root 1 plus y squared minus away 2y squared. That's on the right hand side. Then finally, 2y dx squared, you have to divide by root 1 plus y squared. And something is wrong. Oh. Did I plan this question wrongly? That's not 6y squared. Oh no. I'm so sorry. I think this one I'll get back to you on question 6. I have to check again.
Okay.
Sorry, there's some error. Maybe I made a mistake somewhere. I need to go and check. I'll send you a solution after class. Then question 7, let's go. Next one. Maclaurin series. Next one is y equals to 2 minus e power 2x to the power of 1 over 4. So part A, you want to show that this guy, y times d2y dx squared plus 3 times of dy dx bracket square equals 2y dy dx. So here are the main moral of the story for this type of question is you don't just directly differentiate it. Instead, you do some algebra first before you differentiate. So what I like to do is raise to the power of 4, raise to the power of 4. Then this will give me y power 4 equals to 2 minus e power 2x bracket power 1. Power 1 means I can drop it. Yeah? Good, then differentiate both sides. So differentiate y power 4, you get 4y cubed multiplied by dy by dx. Differentiate 2, you get 0. Minus sign, leave alone. E power 2x, you get back the same thing. Then you times 2. The derivative of the 2x. Then how? You need y times d2y by dx squared plus 3 times dy by dx bracket square equals 2y dy dx. Okay, this one I'll simplify as minus 2e power 3x. 2x. How to continue? What do you think you want to do now? Look at the object. What do you have?
I have
what you have dy dx. What do you want?
I need it to be squared.
And more importantly,
need second derivative.
Okay, good. Okay, I write it
So
neatly.
differentiate the whole thing.
Oh, right, yes. So we're gonna differentiate the whole thing on both sides. D by dx, d by dx. So on the left-hand side, there's a product, so you have to use product rule. I keep changing the way that I write the product rule, but I hope you understand how to do it. Is it okay? Like
which part?
I don't strictly follow this form. Okay, why the form that I
Or
usually use is
D1 keep the
prime. I use keep one, then differentiate the other, plus keep the other, then differentiate one. I use this form.
Yeah.
It's the same, huh? Can
Yeah.
Okay, good. Now I'll just use that second form. That's the one I'm more familiar with. Keep one, differentiate the other. Plus keep the other.
Isn't it like the same thing?
It's the same thing, yes. I'm just okay. You can understand. That's a good. I was just scared that you are confused. Okay, no confusion then, very good. Yeah, it's exactly the same thing. So for y cube, you differentiate, right? What do you get? 4 leave alone. Y cube differentiate, you get 3y squared. And then don't forget the dy dx still. This one you can go a bit faster. 4 times 3 is just 12. You don't need the brackets anymore. So 12y squared times dy dx equals to, differentiate this guy, you get negative 2 outside. Differentiate e power 2x, you get 2 e power 2x. And this is just negative 4 e power 2x. Right? Okay, good. Then I clean up a bit more. 4y cubed times d2y dx square plus, here you see dy by dx times, there's a
dy
time that is
dx
not possible.
square.
Okay, very good. You end up with the square of dy dx, not d2y dx square. Okay. Can wow, very good. You can understand already. Can now you just look at what we want. 3 times of dy by dx square get squared. Then we got 12y squared times dy by dx squared. So we try to manipulate this so that we end up with what we want. 3 times of that guy. So what must be factorized in front of it? Must be 4y squared. Can you see? 4y squared times 3. You factorize the
Yeah.
12y squared. All right. Good. So I'll just copy down the rest of the things that didn't change. Very good. So what we need? We don't want the 4y squared. So what should we do?
Divide everything by 4y square.
Yes. Let me try and write it neatly. So, this way. Oh. Can see the pattern now.
Hmm.
So then this one you can split it up. So it's 4y cubed times d2y dx squared over 4y squared plus 4y squared times 3 times dy dx bracket square over 4y squared equals to 4 and 4 cancel away. You're left with negative e power 2x over y squared. This one, 4 cancel away. I use a different color. 4 and 4 cancel away. Y squared and y cubed. This becomes 1 copy left on top. This is 1, this is 1. So 1 times y power 1 over times d2y by dx squared divided by 1 times 1. That's just y times d2y by dx squared, which is exactly what we needed at the beginning. Oh, plus this one, 4y squared cancel away entirely. Then you are left with, okay, maybe more need to put 4 cancel away, y squared cancel away. Then you're left with 3 bracket dy by dx bracket power 2 equals to this guy. So what do we need? We need 2y by dx times dy dx, right? So how? That's when we have to be a bit clever. So let's see 2y times dy by dx. We can always work backwards. We don't always have to go forwards. So we can start with what the conclusion we need and then just substitute in with everything we have. We already know what is it? We already know what is dy by dx, right? dy by dx is, where can I find the expression for dy dx? Over here, right? 4y cubed times dy by dx equals negative 2e power 2x. So I can make dy dx a subject. Maybe I'll use blue. dy by dx equals to minus 2e power 2x divided by 4y cubed. Okay. That means I can sub in my expression for dy by dx. And anything to cancel away? Y and y cubed becomes y squared. Times 2 divided by 4. So all the 2's cancel away. Right? Then you're left with negative sign e power 2x over y squared. That's exactly what we need.
Yeah.
What a coincidence. Of course it's not. Then from there you can just kind of work backwards if you really want to. You can say, oh, I realized that you can factorize as 2y times negative 2e power 2x over 4y cubed. Right? Nothing wrong, right? Right hand side, just substitute in. And then this actually equals to 2y times dy by dx. And then that's exactly what we need. Proven. Sorry. No, shown. I was correct the first time. Okay, that's it. Okay. So you just have to be clever with the algebra. All right. And let's summarize our findings because in part 2 we need to find Maclaurin series for y up to and including the term in x power 2. So here, if it's up to x power 2, we only need up to which derivative? 2, so we go up to d what by d what? Like this, can you hear me?
Yeah, I can hear you.
Up to which one? Power?
X square.
Up to x squared, so you only need until Which derivative? Do you need a third derivative?
No.
No, only up to 2. Oh, just follow the highest power. Okay, so we already have that one. d2y dx squared. So do we need to differentiate another round to get the d3y?
No.
Don't need. Okay, good. So let's summarize our findings first. We have, okay, actually I should just clean this up. I don't need power 4. Yeah, I don't need the power 4. Okay, remove. I need the original y. I need dy by dx. Where can I have that? Oh, over here. dy by dx, the blue color one. This is still quite simple. If you don't want to simplify, you can always use the original form, which is, let me copy it down. 4y cubed times dy dx equals to blah, 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 working in the middle, don't care. I just need the summarized idea so that I can see it clearly. What else I need? I need the second derivative, right? I have y, I got dy dx. Now I need the second derivative. Where can I find the second derivative? Oh, it's the identity that was provided by the question. So if you cannot solve for you cannot prove this identity, don't worry, you can still use the result for the next line, which is to sub x equals to 0. So what happens to my y? Or in other words, y bracket 0. Sub 2 minus e power 0. 2 times 0 is 0. So the power of 1/4. So e power 0 is 1. So 2 minus 1, which is just 1. So the power of anything is just 1. Okay, so now we must remember x equals to 0. So far, y equals to 0. Y equals to 1. Then that means that dy by dx here equals to minus 2 e to the power of 2 times 0 over 4y cubed. But my y is, what's my y?
Your y is 2 minus e to the power 2x to the power 1. 1.
It's just 1. Yes, so that means you can substitute in the 1 over here. Is it clear? You see the y over here? You can just use the answer from before. So always go down from the lowest power to the highest power when you're substituting the x, because most definitely you will have to use the answer from the lower powers to substitute into the higher powers, or higher order derivatives. Y can be considered as the 0th derivative. Or this is the first. Okay, then now we go to the second level, second derivative, d2y dx squared. Sorry, I forgot to simplify this. E power 0 is 1, so -2. This is 4 times 1 cubed, which is 4, -half. Okay, now we go to the second derivative. We don't have the direct formula for it, so no, we don't try to make it a subject. Don't make as a subject. Don't subject. Instead, you use this guy instead. So don't simplify, don't use the simplified version. Just use the more complicated expanded version. So because we can just directly substitute the values, you can just directly substitute the y of 0. This y, when you sub in x equals 0, becomes y of 0. This d2y by dx squared, when you sub in x equal to 0, it becomes times d2y by dx squared. You draw a line x equal to 0. Plus 3 times dy by dx,
1.
draw a line sub in x equals 0. Square equals to 2 times y of 0 times dy dx, when x equals to 0. Okay, yeah, you get the pattern. So now this becomes, let's see, I can't remember. Okay, 1 times this guy. Just to keep things simple, I'm not gonna write down the line x equals 0. Technically, I should write down line x equal to 0 because I substituted x equal to 0 already. So they are a bit different. D2y by dx squared is the algebra, just x, no, not a number. Not yet. Then only after I draw a line x equal to 0, I replace the x with an actual number 0, then I'll get an actual value. Okay, this is an expression in x. This is a number. So I'm just being lazy here. Technically, I should put a line x equals 0, but I just write this notation. I hope you're not confused now. Okay, then plus 3 times of dy by dx when x equals to 0. We already found out it's -half.
-half.
Squared equals to 2 times of this guy is 1 times that guy dy by dx when x equals to 0, which is -half. Clear?
Mm-hmm.
Good. Then now you simplify, so you end up with d2y by dx squared. 1/4 times 3, so 3/4. 2 cancel away, -1. This guy bring over d2y dx squared equals to 7/4, right? I hope I'm correct. Should be correct, huh? Okay, good. So now we get -7/4. Then what do? Let's just summarize our findings. It's always good to summarize the findings like this so that you have a rough paper format, so that it's easy for you to finally conclude the Maclaurin series expansion. Oh no, don't fly away. Okay, I need a bit more space. Draw a line. Then finally, y equals to, you copy down y0, that's 1. You copy down first derivative, -half, divide by 1 factorial times x power 1. Plus, you take down the second derivative, which is -7/4. And you divide by what? Remember? 1, 1. What's after 1?
2.
2 lor. So divide by
2 factorial
times x to the power of
2.
2. Then after that, if you have the third derivative, it will be d3y by dx cubed when x equal to 0. Wow, the handwriting. On the numerator, divide by 3 factorial times x power 3, and so on and so forth. But we don't need this, not relevant. Not requested by the question, then don't do. And that's your answer already. Just simplify the rest. Okay, we clean up. 1 minus half x. -7/4. 2 factorial is 2. 7/4 times 2, 8. X squared. Okay, that's the answer. Okay. Good. Next question. Let's go. We were at 7. 8 and 9 done. Question 10. Finally, let's go. So here, we got what? Let's see. Theta is measured in radians, small enough so that theta cube and higher powers of theta can be ignored. So this is basically telling you that sine theta is approximately theta, tangent theta is approximately theta, cosine of theta is approximately 1 minus theta squared over 2 factorial, which is 2. Can? Yeah, so we're going to use these small angle approximations. Okay, you're just taking the Maclaurin series expansion, but you ignore higher power terms. Higher powers of, in this case, theta. Now we replace with theta instead of x to confuse the student. Okay, so now in this case, part A, let's see. Tangent of theta plus pi over 3. Can you just approximate this as just theta plus pi over 3? Yes or no?
No.
No, because this is too big. Oh, you must remember you're approximating Maclaurin series, right? Like usually tangent graph will look like this. Then when you come up with a Maclaurin series expansion for it, it will be very close to it for small values of x. Then later on, maybe it will go down to infinity, go up to infinity. Then it's very, very different from the original curve. So it's only a good approximation for small values of x. This guy is not small. This is not, this will, when you have theta plus pi over 3, you're going to be somewhere far, far away already. Too far away. This will be, if the x-axis is here, this will be your theta plus pi over 3. Then this will be your approximation. The y of theta plus pi over 3. Where y is the Maclaurin series approximation. The black color curve. Okay? So, too big, what do? You have to use your expansion formula for tangent, or what we call compound angle formula for tangent. So tangent of A plus B is how much? It is actually, if you look at the MF26,